Netflix, we tend to hire some of the best software engineers in the world. Our model for hiring software engineers is to hire people that are senior software engineers. So generally, average engineer at Netflix has about 10 years experience. We don't do any college recruiting. And then we relocate everybody from around the world to this beautiful campus in Los Gatos, California. And a lot of the reasons we do things like that is to make people as effective as possible, as soon as possible at Netflix. But there's some challenges with that, because Netflix is a very complex environment. When you join Netflix, there's a lot of things you have to learn. If you haven't ever deployed into the cloud, you have to learn about AWS, which you may or may not come in with. If you're, say, a Java distributed systems expert, you're going to have to learn about our platform, our runtime platform called Carry-On, which is in charge of the runtime. You have to learn about our service discovery framework. You have to learn about our KAIS, our fast properties toolkit, which enables feature toggles, which is a critical part of continuous delivery. Hystrix, our framework for doing circuit breaker or essentially implementing bulkheads in production to prevent failures across the whole system. Atlas, our real-time monitoring. Fit is a system we have to inject failure into the production environment. Ribbon, our IPC. And Chaos Monkey, our famous Chaos Monkey, which will go into production and kill instances running in the environment. These are all frameworks, and there's a lot more that you have to learn. And this really makes building services at Netflix a very complex endeavor. And this is just in the context of just the runtime environment as an engineer. So Andy and myself, who will be in the next panel, are parts of engineering tools. And our charter is to enable engineers to be effective at building, testing, and deploying software at Netflix. But what we end up doing is giving them more things to learn, right? So they have to learn about Git, they have to learn about Nebula, our build system, which is based on Gradle. They have to learn about dependency management and the tools we use, how to access the cloud through our bastions, our baking process, which involves taking an AMI, taking your application and then baking it into the AMI and saving that AMI, and that becomes our unit of deployment, a VM. They have to learn about Jenkins, Artifactory, and Andy's amazing tool, Spinnaker, which I'm sure he'll be happy to talk about, which is our continuous delivery and cloud platform. And what this means is that not only is building a service at Netflix hard, but building and deploying services at Netflix is very, very hard, very complex. And what this leads is to a very high cognitive load that we as an organization put on engineers. So we hire the best engineers, and they're experts in their field, and they're experts at writing software, but we still find that they are as not effective as we would like. And so as an engineering tools organization, our goal is to reduce this cognitive load. And so we're kind of targeting how we can reduce cognitive load on engineers and looking at the tools that we implement and making the simple possible in our tooling. So giving the opportunity for someone who maybe isn't an expert in Gradle and to basically use an abstraction layer that allows them to not have to handcraft Gradle builds, or maybe abstracting the version control system a little bit. But if you really want to dig into the version control system or Gradle, then being able to do that. Abstracting any of those unnecessary complexities, which I alluded to. And then really creating intuitive user interfaces so that I don't have to read the docs to learn how to use a tool. And this applies to command line tools as well. Really focusing on getting the command line tool to have a nice intuitive interface, help, and then really integrating these toolkits together. So all those tools I mentioned, typically teams maybe have challenges weaving them all together into a cohesive pipeline. We really want to make that a single pipeline, a single toolkit that they can just download and then run from their machine. And we're really refocusing on this concept of developer productivity and how we as an organization can really make developers as effective as possible, get the tools to just do the job, get out of the way so they can focus on implementing business logic.
So I represent the IT side of VMware. So can I talk about, we're trying to implement CDCI practices within our world. And actually the three big reasons we are trying to go down this path. So first one is, as a company, our business is changing, right? As, we've been a perpetual software company, sell software, collect all the money up front, and then we provide the support. But we are moving more into as a service business where our engineering groups are providing services which are 24/7. And we as IT are joined at the hip with these guys. So, we need to provide our features and functions which support the engineering in that fashion. So that's kind of driver number one. We have no choice that we have to support our products. The second big reason is traditionally we've been a really good delivery shop within IT. So we deliver everything on time, on budget. But typically our way of solving the problem is to throw bodies and throw hardware at every problem. And now we are at a point where it just doesn't work. We just can't scale. We need to go figure out how to get more nimble and agile. Good projects aside, more and more our demand is becoming very, try this out, put something in production in nimble and agile fashion. So we need to go figure out how to get projects a little bit more smaller and get it out faster. And then the third big reason is if you look at our hiring, unlike Netflix, we are hiring quite a bit of NCGs here and in some of the other countries outside. Our employee base is very technical. So if you look at our applications, especially the internal applications, they're all moving towards mobile social application base delivery from delivery perspective. So, and we just don't have a choice to come back and say that, hey, here's your mobile application, get in line, it'll be delivered in 6 months. So we have to figure out a way to get those types of applications really faster. So looking at these challenges, I'm going to talk about what are the issues first and how we solve it. So if you look, the first big issue when we embarked on this journey last year was, as I said earlier, we were really good in what we did. We delivered everything that was asked of us. Money was not a huge issue, so it didn't really matter. So we did deliver. But when we embarked on this journey, the biggest issue we had was from people mindset on why are we changing this? What's the big reason? When it's working, what's the point of changing our methodology? So getting people to focus from this release mentality to more how do you look at a feature and deploy it end-to-end faster was one of the big challenges for us. Our development and operations organization completely had all the conversations through documents and artifacts. Traditional dev and ops model, our DevOps didn't exist. So, we had to move towards this mechanism where we started to form smaller teams and gave them the objective of delivering project rather than having these departmental handoffs. The second big issue was how do we get started? Now, when you're delivering 150 projects in a year and everything is working great, how do you even start to change and how do you start to sell to your stakeholders on that this is the right way to do stuff going forward? So the way we handled that situation was we created a pilot last year. We put 9 projects in this pilot and measured the results. We took the baseline results from how if we would have done these projects in traditional methodology, what would it take, and then measured with the results we achieved with the newer CDCI practices. And the results were very encouraging, and I've got it in the last slide here. But that was the way we took the metrics and basically got our stakeholders aligned to this practice going forward. This is our tool chain. Again, nothing very complicated. For the most part, we've been using Bamboo for build for quite a while. We continue to leverage that, using our custom Python scripts for deployments, and then use open source Selenium and HP's QTP software for testing. All this is orchestrated by VMware has a product called VRCS, which basically does end-to-end orchestration for the deployment CDPs. Just going to flash some of these goals, and I'm sure we'll talk about these. But ultimately, we definitely saw a huge amount of throughput improvements across the board. We got more objects out there. And then the other big benefit was the deployment times.
All right. So for us in Verizon, it's a slightly different problem, and I'm not going to just focus on tools or tool chain. So if you think about what we offer, we actually offer consumer network services from Washington to Boston on the East Coast. We have an international business that basically services all of the Fortune 500 companies, and then we have a very national wireless business that covers coast to coast. And if you look on the left-hand side of the screen, you can see the demand on our network. We heard about big data, we heard about video, and all of that. All that traffic, when it goes through our network, you can see year over year, wireless growth has been 100%, 50%, and so on, and it continues to grow at that clip on a year over year basis. You look at our consumer business as well as our global IP business, all matters of our network have been doubling and doubling every year. However, when we take a step back and look at our own ecosystem, we actually don't produce all of the technologies. We integrate the technologies in partnership with 30+ major vendors around the world. And when you think of the software industry, there is software-defined data center. You have the compute, that's a commodity. The storage, that's a commodity. For us, the revenue per bit has gone down, but really we haven't figured out a Moore's law to really take our PPF up to a whole different curve where we could reduce our cost per bit that keeps up with the pressures of the demand on the network as well as the revenue shrink. So that's really our big problem. So our big objective has been, what is it that we can learn from the web companies and the software companies to really apply in our ecosystem and change the cost curve, if you will. So there's 5 different strategies we have basically chosen to deploy in our ecosystem. All right, we'll stay there. Thank you. And I'm going to only cover on 2, but really, I just wanted to show it for completion here. I mean, we're looking at how do we really take the network, which has really not become software-centric. It's still based on very commodity hardware, and try to make that software-defined. And that's work going on with a number of different partners, both in this room as well as outside. And then we're thinking about how do you leverage big data and really optimize the deployment of capital as opposed to continuously deploying new capital in the network. How do we get a lot more efficient with just-in-time deployment of capital? Keep in mind, we spend $17, $18 billion a year. So any kind of efficiency we can get over there makes a significant difference. And then on the third piece you see on the right is really about virtualized computing and so on, and that is about our own infrastructure. But the 2 big areas that we're really looking to change is, one, how do we change our operating model? How do we take new products into our network in partnership with the ecosystem in a much more agile way? And then how do we transform the whole technology delivery, not just inside of the company, but in partnership with all of our vendors? So one is internal focused, and another one is with vendors and partners. So for us, it's not just DevOps, it's also about a very agile delivery. So if you look at this page, which is a bit of an eye chart, but I'll try to cover very quickly. So if you think of a typical waterfall, for us, it's not about, oh, let's just take the inefficiency out of the waterfall. But with that waterfall, we work with a lot of our vendors, and we take their technology, we put it in our lab, we put it for a period of time. When that technology is in our lab, we actually work on the operating systems, and then when you find an issue, you go back to our partner, come back to our lab, and that whole journey is between 18 to 36 months on a good day before you can launch it in our network. So for us, it's 2 things. One is, how do we partner our internal development teams way up front in the planning cycle so we know exactly how to build the operating model, but taking it one step further, how do you work with your partners so that you're not going through an account team and a sales team where you're just a feature on their dev team list versus partnering really dev-to-dev basis. So that's really the first piece. And the second is, our historical mindset has always been like, let's get all the features. If you buy one box and it can give you 1,500 features, let's basically test out each and every feature, because product development used to come after network technology deployment. So that whole cycle we're trying to change by saying, hey, what is the product that our end users really want, and can we actually consume a portion of the features without really taking all of the features? So the definition of minimum viable for us starts to extend all the way into the technology that we procure from our partners. When you think about manual sequential testing, because we work with so many vendors, in many cases we've become the interoperability testers as well. So now the question is, what needs to be true about those outputs so that we can actually consume in our own environment? And then we have every vintage device you can think of. Pretty much from the Pony Express days to today, we have every equipment that was deployed in our network, and part of our challenge is how do you basically eliminate the legacy and just move on to the next generation. And then we talk about culture, but the biggest cultural change for us is to create multi-talented people and to get people to accept that they can take a little bit of risk in this process. Because we were always guided by 5 nines, and therefore, the culture is a little afraid to take any risk that might potentially jeopardize the 5 nines of availability. So multi-talented teams as well as a little bit of risk tolerance are very important for us in our own ecosystem. So with that, what I would really like to sort of challenge ourselves collectively is not about how do we go through this journey, but how do we really take Agile as a process, work together as an ecosystem so that we can move from this N to the power of M kind of complexity we have in our network to a linear or a sublinear complexity. Because when we bring in all these technologies and integrate it and offer it on a global basis, just that complexity prevents us from being very agile. So that for us is one big challenge we need to solve for inside as well as collectively with the industry. Second is, we have never scaled our networks exactly like the way the web companies have been able to scale. And that's a challenge for us with our partners as well as new innovation, working with the smallest of companies to the largest of companies to figure out what does web scale mean for us. We talked a little bit about leveraging our assets, but we also need to be thinking about how do we drive more revenue with our current assets so we have the leeway to be agile and introduce new things, because we as an industry are very, very bogged down by our infrastructure capex investment. And then lastly, of course, it's not just continuous integration for us, it's really continuous innovation, because that's the only thing that stays constant for us in this industry.